Hello everyone. So today starts our lesson on parallelograms. A quadrilateral is a parallelogram if both pairs of opposite sides are parallel. So in our figure ABCD, A, B, and CD are opposite sides, so they're parallel. And AD and BC are opposite sides, so they are parallel as well. Now, with this basic information, we can discover a lot of interesting properties about parallelograms. So, let's look at this first problem, 8.9. Given that the measures of the angles of parallelogram ABCD are shown, find x, y, and the angle at C. So, the only angle we are really given the full measure of is the angle at D, which is 30 degrees. Well, looking at what we have so far, I know that the angle at D and the angle at C are on the interior of the two parallel lines AD and BC, but they're on the same side of the transversal DC. If you remember yesterday's lesson on quadrilaterals, we know that same side interior angles are supplementary. So, angle C plus angle D are equivalent to 180 degrees. Well, we know the angle at D is 30 degrees. And with some basic math, subtracting 30 on both sides, we are left with angle C is equal to 150 degrees. So, that gives us our first angle measure. So from there, we can say that angle B and C are also same side interior. They're on the interior of the parallel lines AB and DC, same side of the transversal BC. So we know that the angle at C plus the angle at B is equal to 180. Do a little bit of substitution. The angle at C is 150. And the angle at B is 3x. We also can just subtract 150 on both sides to figure out that 3x is equal to 30. And therefore x is equal to 10 degrees. So now we have two of our answers. It should be easy to find the last one, and we can just use the same logic we've been using already. The angle at A and the angle at D must be same side interior. So same logic we've been using. Angle A plus angle D is equal to 180. And the angle at A is x plus y. The angle at D is 30 degrees. That's equal to 180. Or, yep, not 150, 180. So I'm going to replace the x with 10 degrees. We have our y. If I subtract 30 on both sides, we have 150 degrees. And subtract 10 degrees on both sides, and we are left with y is equal to 140 degrees. Now, one thing to note is that after solving for the variables, we can conclude that the angle at B must be 30 degrees, because if x is 10, 3x must be 30. And the angle at A is going to be 150 degrees, because we have 10 plus 140. And if we look at our diagram, we notice that the opposite angles, like A and C, are the same and D and B are the same. And that is something you can show in any parallelogram.